Hello everyone, it's a pleasure meeting you all in my mathematics class. I am continuing with my convergence and divergence of series. I have taught through my lecture classes the test of convergence using p-test and D'Alembert's ratio test. Today I will take yet another method, which is namely Cauchy's root test for the convergence of the series. See here, let us consider a series which have only positive numbers. In the sense it is a positive series. That is sigma of 1 to infinity un, where un, every un is a positive number. It is a positive. Therefore, this is a positive series. How to find whether this series is a convergent or a divergent one? That is the question. For which I told you that we are using what is called the Cauchy's root test. The Cauchy's root test says that you take this un, which is un is nothing but your nth term, and you take the root of 1 by root of nth root of un. What is this? This is nth root of n, and allow n to tend to infinity and let it attain a finite limit L. I repeat once again. You take the nth term of this. Here un is nothing but your nth term, and take the nth root of this and allow this n to tend to infinity and let it attain the finite limit L. If this L is less than 1, then this series sigma of 1 to infinity un is a convergent series. If it is greater than 1, it is a divergent series. If it is equal to 1, the test fails. Equal to 1, test fails. I will come back to this after explaining you how to do a problem. I will come back to this. That is, the Cauchy ratio test fails if L is equal to 1. I will tell you why that is so after taking up a problem and explaining you how this Cauchy's root test is applied. After completing that, I will come to this problem. Okay, I will explain this particular part. After this part will be explained. I will tell you, give you in brief what is this. Okay, now let us take this. So I will take an example of this. Here you are given. What is that you are given here? It is the convergence of the series. In all my videos, in all my lecture classes, you may find one aspect that given a series, if the series is given fully, it is for you to use your knowledge of finding the nth term. Okay? And if you are given nth term as such is in the problem, there is nothing to worry. But if it is not given, if the series is given, you have to use your mathematical knowledge and what you have learned in order to write the nth term. Now here you are given in this problem, this is a series. The series is 2 to the power of 2 divided by 1 square, 1 to the power of 2 minus 2 by 1 whole to the power of minus 1, and plus 3 cubed. This is 2 square, this is 3 cubed, this is 1 square, this is 2 cubed. 3 cubed divided by 2 cubed minus 3 by 2 whole to the power of minus 2 plus 4 to the power of 4 divided by 3 to the power of 4 minus 4 by 3 to the power of minus 3, etc., etc. It goes on up to infinity. Here you find that in order to apply the Cauchy's, I am going to explain how we are going to apply the Cauchy's root test, for which you must know what is this nth term somewhere here. What is the nth term? Can be anything. So you see that, so when you put nth term, if you put n is equal to 1, you will get the first term. If you put n is equal to 2, you will get the second term. If you put n, so you must be able to get the whole series if you put n, if you start giving the values for n. That is the meaning of that. So you see that, here n, what is this? This is n. Here 2 square, 3 cubed, 2 square, 3 cubed, 4 to the power of 4. So you see this is n 2, 3, 4, 5, 6, like that it goes on. So you see that what is the nth term here? 2, see it goes like this. 2, 3, 4, like that it goes on. So it is nothing but your nth term will be what? A plus n minus 1d, because you see that here the common difference is 1. So a is 2, 2 plus n minus 1 of, here common difference is 1. So you see that n plus, this is n minus 1 plus 2 will be n plus 1. So you see that here n plus 1. The same thing goes here. You can see this 2, 3, 4, like that it goes on. So again for this power it is also nth term. So n plus 1. So here I will explain this. 2, 3, 4, 5, 6, it goes on like that. So it is an arithmetic series with a common difference 1. That is 2, 3, 4, 5, 6, like that it goes on. The nth term of a arithmetic series is a plus n minus 1d. It is a plus n minus 1d. Here a refers to the first term 2 plus n minus 1. What is the common difference? Common difference is 1. Your common difference is 1. So you see that the common difference is 1. So a plus n minus 1, 1. So this is 2 n minus 1. So n plus 1. So I am getting it as n plus 1. The same is the series as the power. 1, 2, 3, 4, like that it goes on. So n plus 1 divided by, what is this? Is 1. It starts with 1, 2, 3, 4. So you can see this 1, 2, 3, 4, 5. So here again you see that what is that nth term? Nth term will be your n. What is your nth term? So nth term will be n. But here you see the power is 2, 3, 4. Here I give it 2, 3, 4. What is the nth term? Nth term is n plus 1. So this is your nth term, which is the n plus 1. So you see that here 1, 2, 3 means n to the power is n plus 1 minus, this is 2 means what? N plus 1. And this is n whole to the power of, it is minus 1. See, leave alone, don't take this, minus 1, 2, 3, 4, 5, 6, it goes on like that. So nth term will have the power n, but it is all negative, that you get it as minus n. So we have found what is called our nth term. So getting the nth term, writing the nth term is very, very important. Here understand that, here I have explained to you how we are getting the nth term for this, for the numerator, nth term for the denominator, and for the whole power. So I have given you the full idea of how to get that. Okay. Now, what I do is n plus 1 divided by n whole to the, see, this can be n plus 1 is a common power. So you see that it is n plus 1 divided by n whole to the power of n plus 1 minus n plus 1 by n whole to the power of minus n. Now what I do is I raise, because in order to apply the Cauchy's ratio test, I raise this a n to the power of 1 by n. If I raise it to 1 by n, see, I raise on the right hand side also to the power of 1 by n. So when you raise it to 1 by n, this n and n will go off, giving you n plus 1 by n to the power of n plus 1 minus n plus 1 by n whole to the power of minus 1. So this minus 1, you must know that x to the power of minus 1. See, what is your x to the power of minus 1? Is equal to 1 by x. X to the power of minus 1 is 1 by x. So you see that here this is to the power of minus 1 is 1 divided by this. Now what I do here is, you can find that this n plus 1 by n, here n plus 1 by n is a common factor, common term. So pull that outside. So you will be left with n plus 1 by n plus 1 divided by n whole to the power of n minus 1. See, you see, multiply this, you will get the first term. Multiply the second, you will get the second term. Then you see that this can be written as, for this can be written as, divide this numerator by n, you will get 1 plus 1 by n. And here it is 1 plus 1 by n whole to the power of n minus 1. So here I divide the numerator by n, here also n by, so that I get it as 1 plus 1 by n, within brackets 1 plus 1 by n whole to the power of n minus 1. Now you take limit n tending to infinity. So limit n tending to infinity of an whole to the power of 1 by n is equal to limit n tending to infinity of this. Now when you apply n tending to infinity, we know that 1 by n is 0. 1 by n is equal to 0 when n tends to infinity. So you see that what is that you get here? It is 1, whereas 1 plus, see, 1 plus 1 by n whole to the power of n, as n tends to infinity is the incommensurable number, which is nothing but e. N tending to infinity will be e. So you see that here in this place I can write. See, can you see this here? So this is 1. This is your 1. Whereas for this value it is e and e minus 1. So 1 into e minus 1. That is 1 divided by, we know that the value of e is 2.71828. It recurs. The number is a recurring number. This is a recurring number. So it is, we stop here. I stop with 7.1828. So it is some 2.71828 minus 1, which is nothing but 1.71828. And this will be, if you divide it, naturally this will be less than 1. So you see that you are getting limit of n tending to infinity of a n whole to the power of 1 by n, which is equal to your L, which is equal to your L. This L is less than 1. Since L is less than 1, the series 1 must become, where is 1? See, this series 1 is a convergence series. Are you able to understand? So what we do is, here it is very simple. Writing this nth term is very, very important. After writing the nth term, you allow this n to 10. Do some adjustments here. Bring it to the form always 1 by n form, so that when n tends to infinity, 1 by n will become 0. Whereas 1 plus, see here you must know, 1 plus 1 by n whole to the power of n, or 1 plus n whole to the power of 1 by n is also equal to e. You must know that. So this is 1 plus 1 by n whole to the power of n. When n tends to infinity is your incommensurable number, which is the exponential series number e, and this is equal to 2.71828. When you apply that and you see that this becomes less than 1, but as per Cauchy's root test, if an, that is a limit of n tending to infinity of an whole to the power of n, 1 by n is equal to e, L, which is less than 1, it is a convergent series. Hence, this one is a convergent series. Okay, so this is how we do. I will do more problems to make things very clear. I am sure that I can give you the best to see that you are able to understand even the basics and everything very clearly. Okay, now as I told you here, one information I gave you, that how it is, see, it is less than 1 means convergent. If it is greater than 1 means, see, if it is less than 1 means convergent, greater than 1 means divergent, I told you. But if it is equal to 1, why we say that the test fails? See, you see that? If, C or the Cauchy ratio test fails if L is equal to 1. The reason is that, the reason I will tell you, so I will give you some. See, we know that limit n tending to infinity of 1 by is equal to 1. This is equal to 1, and this is a known thing, and limit of n tending to infinity of n to the power of 1 by n is equal to 1. Now, see, consider sigma of 1 by n. You are taking this un, see, take un is equal to 1 by n, and the series is sigma of 1 by n, and vn is equal to 1 by n squared. Series is sigma of 1 by n squared. We know that this series is convergent series. We know that this is a convergent, this is a divergent series. This is a divergent series. Whereas this is a convergent series. This is a convergent series. Now let us apply, see, we will apply Cauchy's root test. That is, see, un to the power of 1 by n, limit n tending to infinity of this is equal to, so this is 1 by n, see, limit of n tending to infinity of 1 by n, that is equal to, see, 1 to the power of 1 by n, see, limit n tending to infinity of to the power of 1 by n to the power of 1 by n, that is equal to limit n tending to infinity of 1 by n to the power of 1 by n, that is equal to 1 by n 1. Using 1. So what is that I have done here? So we know that un, if I take un is equal to 1 by n, the series is sigma of 1 by n, but this is a divergent series. We know very well that this is a divergent series. We can go through that p test in p series. In p series you will find that if p is equal to 1, if p is less than 1, it is a divergent series. P is greater than 1 means a convergent series. See here is that this we have got 1 by n, which is a divergence, a well-known series. It's a divergent series. Now you see that I take this series, so un is equal to 1 by n, then un to the power of 1 by n will be equal to 1 by yn whole to the power of 1 by n, limit n tending to infinity of 1 to the power of 1 by n divided by n to the power of 1 by n. But 1 raised to anything is itself. So you see that limit of n tending to infinity of 1 by n to the power of 1 by n. But we know that the value of this limit of n tending to infinity of n to the power of 1 by n is 1. See, it is equal to 1. So we have got the value as 1 here. So, but you must know that this is a divergent series and limit n tending to infinity of Vn to the power of 1 by n is equal to limit n tending to infinity of 1 by n square whole to the power of 1 by n, that is limit n tending to infinity of 1 by n square whole to the power of 2 by n, which is equal to limit n tending to infinity of 1 by n to the power of 1 by n whole square, that is equal to 1 by 1 square, that is also equal to 1, using 1. So you see that whether it is a convergent, when you get 1 here, for this also you are getting 1. But this is a convergent series, whereas this is a divergent series. But in both the cases, for convergent series also it is 1 is coming, the n is equal to 1. For divergent series also 1. But we do not know whether it is convergent or divergent series. In both the cases it becomes 1. That is why we say that if it is equal to 1, we cannot say whether the series is a convergent or a divergent series. Are you able to understand? So you see that is why we say that the Cauchy root test fails if L is equal to 1. The reason is that the series we do not know, they may tend to 1, you will get, but the series can be like 1 by n, which is divergent, or 1 by square, which can be a convergent series. Okay, so we will see more problems in the coming days. Thank you. Do not fail to subscribe to my channel. Okay, thank you.